Under the Department of Science and Technology's Water IC for Sutram of Easy Water initiative, researchers from IISER Bhopal have developed a new material for water purification. This material can absorb and remove toxic micropollutants from water efficiently and cost-effectively in real time. Let us see a report to get more details on this technology.
Over the past few decades, increased industrial development and uncontrolled expansion of industries have contributed towards increasing the water crisis in our country. The chemicals from these industries and the waste generated by a large population have badly polluted our water bodies. Many a time, these pollutants are so microscopic and soluble that it is difficult to separate them from water. This creates an acute shortage of potable water across the country. The Chemistry Department of the Indian Institute of Science Education and Research, Bhopal, has developed an innovative solution in view of this crisis. IISER researchers have developed scalable hyper-cross-linked porous organic polymers or HPOPs as part of a study funded by the Water IC for Sutram of Easy Water initiative of the Department of Science and Technology, Government of India. This material is capable of absorbing and cleaning a variety of toxic pollutants in real time within 30 seconds to 1 minute. The results of this research have been published in the journal ACS, Applied Materials and Interfaces.
We are particularly focusing on certain techniques or developing materials so that we can make this process little bit faster and facile, and it can be easily affordable. So one of the technique is the adsorption. We prepared some sort of porous organic polymers, more specifically hyper-cross-linked porous organic polymer. So these nanoporous polymers, when we mixed with this kind of contaminated water, it can separate a range of micropollutants, including pesticides, herbicides, microplastics, in a very short period of time.
During their 3-year study, researchers from the department, who have been working on porous organic polymers for a long time, developed nanostructured HPOPs from 3 types of chemicals and catalysts employing a simple synthetic protocol. These HPOPs contain numerous nanopores covering a large surface area. For example, just 10 grams of this material, when spread on flat ground, can cover an area of 1 to 2,000 square meters.
We synthesize this polymer using a very basic organic chemistry knowledge, that is Friedel-Crafts chemistry. So here I am taking 3 chemicals. One is my aromatic monomer trypticin, second one is the solvent DCM, which is very easily available, and the catalyst aluminum chloride, which is very cheap in cost, like 1 gram of the catalyst is 1 rupees in price. So these 3 chemicals I mix it in a sealed sling tube, and in laboratory scale we are doing this reaction around 200 to 300 milligrams, and then we are getting around 400 milligrams of my polymers. So which we can scale it up with some modifications.
This completely indigenous solution can effectively purify water over a large area at very low cost. Under the same DST project, IISER Bhopal is now working towards starting field trials of the material in collaboration with IIT Madras.
Currently, we are also trying to expand this work so that we can go for from lab scale to some field scale study and further applications. So for that we are collaborating with researchers in Department of Chemistry and Chemical Engineering in IIT Chennai under that Sutram project framework, and trying to manifest this work in a larger scale.
The HPOPs come in 2 morphologies: spherical nanoparticles and 2-dimensional nanosheets. And according to researchers, the 2D nanosheets show great promise for large-scale applications. After success at the field level, it is hoped that this research will prove helpful in reducing India's problem of pure drinking water availability to a great extent.